tech debt is like there's an ideal, sort of perfect way something could be built. The more trade-offs that we take is what we're trading for. That speed is the tech debt on the back end.
I think it comes in layers, right? So you have a feature to knock out, you get a layer done. That particular layer has some form of this trade-off in it. Each layer of work that's put into your product has some form of set of trade-offs that you take. And so the challenge with technical debt and sort of this building of these layers is each layer has some amount of trade-offs and some amount of compromises that you've made. All right, today we want to talk about this idea of software economics. And I kind of invented this specific definition of software economics, so go with me here. And just humor me for a moment. What I want to hone in on is this idea of, should we build it right now, or should we get it out? So when we talk about economics, I'm discussing the trade-offs of, should I trade implementation speed for technical debt, which is something you see a lot of organizations doing. And we don't really talk about this because it's something that's fairly common in the industry these days. We always hear the adage of, I'll just get to that later. Sometimes you do, sometimes you don't. It depends on the context. But with me today, I have Sam Hosig, Principal Engineer for 7Factor. Say hi, Sam.
Hello.
And I'm excited to talk about this because this is something you and I have been working together for a long time here. And we actually have a few projects together where I remember having this kind of conversation with a customer where they were very frustrated at this idea of technical debt because they unfortunately thought that building software once is all you have to pay for, right?
Mm-hmm.
And so I want to dig into this idea first of what is technical debt so that we can frame the rest of the conversation. Most of the people, if you're listening to this or watching on YouTube, if you've been an engineer for longer than a couple of minutes, you know what technical debt is. But Sam, I'd like for your definition, and then I'll kind of fold that into mine, because I love hearing people's different opinions on what tech debt is, because ask 10 people, get 15 opinions.
Yeah. Tech debt in my mind is like there's an ideal, sort of perfect way something could be built. And then the more trade-offs that we take to just get something out is what we're trading for. That speed is the tech debt on the back end. So there are more things that we are going to need to do to sort of return us to that more ideal state, I guess is what I would say. And the tech debt is what we're paying back to get us back to that, ideal state. And that I think is probably, what we're talking about in very economic terms. But, we also end up with things that are just, purely sort of like upgrades of packages or SDKs or whatever we're ending up there, right? Things that we need to do to make sure that our software is going to be stable and long running, and we're not just going to run into issues one day and scramble because all of a sudden everything fell down.
Yeah, I like to differentiate between those two ideas as there's a cost to maintain your software, which a lot of organizations, as you just put it, we'll call that tech debt. And that is technically, I suppose, tech debt. But I like to think of it as a maintenance cost. Take a mobile application, for example. Mobile applications are very irritating to build because they have such a broad swathe of hardware profiles and breaking API changes. Like Apple and Google, they have no shame about shipping breaking API changes that you have to then maintain and upgrade your app in order to have it continue to work on the newer devices. And we've seen this a bunch in our industry. And I come from a mobile development background, so I even have more context into what it was like 15 years ago, which it was even harder back then than it is today. So the maintenance costs of maintaining your app is sort of something you build into the software development lifecycle, and you've seen people use certain percentages of time to focus on this. But those trade-offs that you're talking about, where we trade up or we trade down rather implementation for speed, and then we have some to dos in the code that we manage later, or perhaps we make some decisions around architecture now that we know we're going to have to manage later, and you write up some tickets in the backlog. That is that sort of technical debt in the sense that your average enterprise customer or enterprise company is going to think about. There are other types of technical debt, though, that you'll trade into that aren't tickets. For example, readability. I know this is a subjective comment or a subjective area of software development. Some people read code and they think it's great. Other people read code and they think it's terrible. And it's all just a complete trade-off and a set of conversations that you have to have around that specific piece of code. So that type of technical debt is often seen when you trade up for speed as well, because I'm just trying to get it out the door. I don't care quite as much about the cleanliness of my code. Maybe I'm less concerned about how organized it is. I leave myself a bunch of notes. I get the feature out. I get it into production. It's a success. We move on. Now, again, there's a lot of nuances to doing that properly, because you can push something that's brittle or perhaps not thought through from a scale perspective. But let's assume for a moment that you do it correctly and you push it out and the value is achieved by the product team. Now, at that point, you have to make a decision for yourself: is how do I manage this trade-off that I have now made, right? How do I come back and make changes to the code base without breaking future sprints? And this is kind of the conundrum that a lot of product companies excuse me, let's pause for a second. This is the conundrum that a lot of companies find themselves in. So from that trade-off, I'd like to explore just for a little bit, how do we balance that idea? So Sam, in your experience, how have you seen, or how have you balanced the need to get something out versus the need to have something that is in the long term more sustainable?
Yeah, I mean, it's definitely it's a tough question to answer, and for me, it doesn't get easier, especially when it comes to like revenue driven pieces of software.
Mm-hmm.
A lot of things that I think that I've worked on, that can drive revenue and bring money into the company are things that people want out there almost immediately, right? Because the
Mm-hmm.
sooner it's out
Right.
there, the sooner it's going to be bringing money back in. And so like
Right.
it's an easier pill to swallow to then, if I have to go back and do something, at least I have a working, you know, feature set out in production, and people are using it, and I can, make money back. Um, the the conversation becomes really tough when there is a sort of like mission critical piece that, as like product awareness, is going to be used today, tomorrow, and hopefully years in the future. And that piece is something that I will look at and say, this is likely not something that I'm willing to have that speed trade off on, or
Right.
hastily coded, because the sooner that we get that to a really good state with good architecture, and not a whole bunch of to dos and weird comments of like, this line should never be hit, so ignore it. Right.
Right.
The mission critical things are where you have to have that honest conversation and say, hey, I know this is going to take a little bit longer, but if we get this right today, we're not spinning back to this in 6 months and trying to figure out what happened, and then we add 8 months to our development cycle. So if it's something that can sort of be peripheral, and it's a nice feature add to something that maybe is either not used every day, or is sort of like a one-off for a specific special customer, like, great, that I'm a little more willing to speed through, and just it might become a little bit lazy at certain points, but that mission critical piece that you're sort of is the main building block of what you're doing is really just like, I tend to try not to compromise on that at all.
Right. I think it's also, it comes in layers, right? So you have a feature to knock out, you get a layer done. That particular layer has some form of this trade-off in it,
Mhm.
right? So you can call your layers may be sprints, your layers may be iterations, it may be days, depending on if you're more of a continuous delivery type approach. But each layer of work that's put into your product has some form of set of trade-offs that you take, right? And so the challenge with technical debt and sort of this building of these layers is each layer has some amount of trade-offs and some amount of compromises that you've made to get your software into the real world, right? And that could be something as egregious as maybe, and I'm going to hopefully not insult some of you, but just ask ChatGPT to write your code. Maybe it's great and beautiful and perfect, but maybe it's also terrible. I don't know. I didn't. If you're a software engineer and you're looking at it and it looks good, maybe it's fine. I don't know. So you're writing your first layer, and that's a feature that goes out, and you have some number of trade offs inside that layer that you have to account for. And then the next feature comes along, and that's another set of layers that have to be managed. And if you think of it, each of these tickets that you're working on is a discrete unit of work. Again, this is an academic perfect land where none of us actually reside, but there's some congruency to this to the real world where I'm working on a ticket, I understand what I'm trying to do, I build the ticket, I push it into production, I move on to my next ticket, my colleague works on their ticket. Sometimes we touch the same code, sometimes we don't. So it becomes kind of a very difficult, almost an intractable problem to manage this concept of each layer of work that a developer is doing. How do we manage those trade-offs? And a lot of frameworks will try and manage those trade-offs for you. I think that testing is one of the most key components to managing those trade-offs. While it doesn't solve for the style and the maintenance problem, it does solve for the does it work problem by using things like TDD and writing unit tests that are regression tests. You can come in behind finishing that particular unit of work and do some changes to make the code more maintainable or to make it have to increase its longevity as it sits in your code base. Which is another interesting thing to think about is how long will this code be active? In today's world, code is built, created, and thrown away at such an incredible speed that there are times when it doesn't even make sense to focus on deepening the quality pool of this particular set of this particular feature. Sam, what have you seen in your projects on this sort of trade-off of, look, it's throwaway, just get it done, versus, okay, maybe we need to spend more time thinking about the architecture?
Yeah, I mean, we've had a couple of instances where we might have, a feature that comes in and we're working maybe with a third party or an integration partner of some variety. And the first conversation goes something like, here's what we have today. And it might be an API, it might be some FTP file that you have to, download and work with in some capacity. But in any case, they have some relatively not ideal or up to maybe what current generation might expect process. And during those first few conversations, they say this is what we have today, but in 6 months or 3 months or whatever, we're working on finalizing our next gen process, and it's going to be broken for what you guys have today. But ultimately, what we're looking at is the service you provide is important enough that we need to get something done. And
Yeah.
so it's a speedy implementation of working with that partner or integration team, which maybe isn't ideal, but sort of to your point, if we know that we are going to spin this up and then 3 months later we have a whole new set of services or whatever the case is to interact with, there's no sense in spending 2 months to build this fantastic, perfect, amazing architecture around a one
Right.
integration partner who's then just going to rip the rug out from under you and say, hey, here's this whole new thing that you need to integrate with now. So that's happened to us a couple times. And it's it's not fun when they say that, but at the same time, like, it's understandable. We have stuff we need to get done. We need to consume your stuff today. And so, we'll sort of take that short route, get it done today, and then work on what is hopefully a longer term solution moving forward.
Yeah, and one of our clients that we recently started working for, the CIO or the CTO, excuse me, had a specific set of dashboards that they wanted us to build for them, and uh, but their customer needed something now in order to continue to work with them. They're a SaaS product provider in the healthcare space, and so one of the things that this person did, and it's a very smart call, is to bite the bullet and execute on getting something out that meets the needs of their customer to continue that relationship. And then they came to us and said, all right, we want you guys to build it for real.
Mhm.
And that's great because that means you're able to kill those two birds with one stone. Yes, you're wasting some time here. And I mean, it is the company's time because it's an internal person who's doing the work. But you're wasting some amount of time, but you are adding business value. You're propping up the business value while you can stand up the real solution on the back end. In addition to that, there's many dashboards that this company would like to create. So it makes sense for us to think through architecturally, how do we build a framework and how do we build a code base that's maintainable in the long run? And it's similar when you're looking at some back end service economics and when should we, for example, take the trouble to split off into a brand new service? I know microservices is a thing and it's a good pattern. It's a very difficult pattern to get right. I think we've realized that in 2024. And it's not really the right pattern for everything. But let's assume for a second that we have a scaling problem that we know we're going to need to solve later. Then it makes sense to spend the time and money to spin up a brand new service, or perhaps convert into a serverless architecture, which has its own trade-offs, or just do something unique because we need to solve this particular business problem. And this is the thing that I think we've departed from in our industry, and I'm kind of happy that we have, is we're not thinking about Gang of Four patterns anymore, right? We're not digging into the deep academia of what is the most elegant abstraction of how this software can be written. And trust me, I'm an academic, so I have some level of respect and perhaps even I pine for those days because it was much easier to just simply apply target pattern in that book and everyone thinks you're a hero. These days, you're a hero for producing business value. You're not a hero for writing elegant abstractions, right?
Yep.
And I think that's the big change that we have to adapt to as developers, and why I want to continue to have this conversation around economics of the decisions you're making on the ground as a software engineer. Because again, it depends on the standards that you have in your organization. Obviously, you should always adhere to those. But you don't want to be a hacker, but you also don't want to be the stodgy academic that can't produce something on a deadline that's reasonable. Obviously, if it's a bad deadline, then that's a different problem altogether.
Yeah, I mean, I'll say one of the things that I've run into, which is sort of the whole idea of like, where is the value coming from, and part of it I think comes a lot.
Mhm.
I see once it's gone to production. Something's gone to production. Maybe
Mhm.
there's a use case or something some bug that's been introduced. Either you didn't know about it or people are using it in a weird way, and now you have to sort of account for it. And there have been a lot of cases where the easy solution is to just keep fixing it one off every time it comes in, because that is quick. It
Yeah.
takes a developer an hour, whatever, and customer then becomes happy again, and you're back to doing what you're doing. Um, but when that happens every day for 4 months, now a developer has wasted, you know, I don't even know what the math is on time, but like it would have been quicker to just sit down
Right.
for a day, figure out the root problem, solve the root problem, and then guess what? We don't have to spend an hour a day context
Yeah.
switching, talking with whoever is our support contact to figure out like, is this the same problem? Like, you know, is this the same solution? How do we adjust this? All of those sort of questions that come whenever a support request comes in, and so that question of like, you know, what are we looking at, and where is value coming from? Sometimes it's easy to look at the like very point
Right.
in front of you where this is a 1 hour solve for us to fix this. Whereas if we were to just take a couple steps back and being able to show somebody, yeah, it's 1 hour here, but also if we take a couple steps back, it's 1 hour here, 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 and all the way through. And being able to show that and say, give me 8 hours, I will fix that. And that solves 100 hours in the
Right.
future. Right. And so being able to sort of, yes, I have a
Right.
solution that is quick, but when do I apply that versus when do I just be able to take a step back and solve your business problem, from a more complete whole solution, is something that I think we run into quite a bit. Just nature of the business where we want to get moving faster and onto new features, but at the same time, there is that question of is it worth pausing new features for a minute to stabilize current, and get back to producing more value.
Yeah, I think a good thought experiment is, let's say that we're building an application that needs to store to an object store, which is like S3, right? Or Google, or what's the one in Azure? I don't remember. Azure Blob Storage? Yeah. So let's say we're building an application that stores things in S3, and then for some crazy weird reason, one day someone decides that they want to also support other clouds' object storage mechanisms. Again, I know this is maybe a bit silly. I'm sure somewhere out there someone has needed to do this for some reason that's, I'm sure, very good. But this particular idea showcases this concept pretty quickly. When we put it together and we got that ticket of build out S3, I guarantee you it said something along the lines of, or it would have said something like, store files in S3, because you're going to call out the technology, or at least that's what I've seen. You're going to call it the technology. We're an Amazon. We're an Amazon application. Of course, we're going to use S3. And then for some reason, again, regulations or some outside force says, now I want you to store that in Google. Now is a great time to sit down and say, okay, should we abstract out the way that we store those objects, or should we just hack together a different set of controllers that store only specific items into Google, and then have the API, perhaps you send a query string, which you shouldn't do, but let's say you make some bad decision to basically swap where it's stored based on some input you get from your user or from your application. That is a place where it would be smarter to create an actual abstraction, right? Anyone who's done OOP for a minute would say the first thing I'm going to do is I'm going to look at the code that we wrote for building S3 that we put together quickly, because that's the business need. And now we're going to look at abstracting that out, because who's to say someone isn't going to say, I now want to support Azure. You've already asked me for GCP, so I'm going to go ahead and build it right. And that's a case where I personally would push very hard to solve the problem generically, right? And I think this is the real challenge that you're solving when you do this economics software sort of trade-off is, should I generate technical debt with a more specific solution that I know I might have to abstract later? Or what's the likelihood that I'm going to have to build a more generic implementation later, right? And also, what's the cost or the trade-off to do it right now? There's plenty of frameworks that are very good at giving you abstractions out of the box. So it's very easy and simple to plug into a framework where later concrete instantiations of business logic is very easy. Spring MVC, .NET, whatever the .NET MVC, I guess there's something even newer than that these days. But all these frameworks give you this almost for free out of the box. So you as a developer, and this is really the crux of the conversation, the experience that you have as an engineer is really what dictates if you can do this or not, right? A fresh software developer out of school is not going to have the capability to make an informed decision on trade-offs for a large software system. They're just not, right? They don't have the experience and the scars that many of us have to be able to make those trade-offs and to make those calls. And this is where in your organization, it's incredibly important to have your top software engineering talent driving these kinds of conversations. Because the people that have been doing this for a long time are the ones that can say, you're saying that's going to take 2 days. I know that's not right because I've done it and it takes a lot longer. So we're going to budget 5 days for this, and we're going to do it right, because if you half-ass it, it's going to turn into a big problem down the road. So your senior talent, your team leads, your staff software engineers, these are the folks that should be sitting in between product and in between your user experience teams and the rest of the engineering teams and your scrum masters or whatever, however you run your process. They're the ones that should be helping make the call on those trade-offs, right? Because I particularly don't believe in an ivory tower of architecture, although it is a pattern that can work as long as the folks in that tower are benevolent. But pushing your team leads and your senior engineers to drive that knowledge and experience back down into the team is the best way to make those trade-offs. Because, again, the most experienced folks in your team are the ones that can make those trade-offs the most effectively.
Yeah. I mean, I think, to that point, where you're going to see a ton of benefit, maybe, somebody who's been around the industry for a while might see that benefit even on smaller scale or on long-standing products where it maybe is a little bit more nuanced in how some of that presents itself. But I think what we've seen, and I know on some projects that I've been a part of, when you start net new, there is a very easy case to find yourself in, which is, I'm building a proof of concept. It is relatively, it's there to show that we can make a happy path work. It's not robust.
Right.
And then everyone says, hey, this is awesome. And then throws features at you and says, hey, we need these next week. And all of a sudden that, quick, not super well architected, but it works piece that you started with is now sort of a house built on toothpicks, essentially.
For sure.
It could fall down at any time.
Yeah.
And so, when you have that senior person who's sort of been a part of things for a while and can sit there and say, yes, this is a proof of concept. The closer I get to being able to show this to somebody, the more I want to caveat what's done. So that conversation that happens after that says, well, cool. How do we, set this in production and get it in front of people? And they can say, hold on, pump the brakes real quick, because in order to make this an actual production application, we need to do X, Y, and Z to make sure that this thing is actually going to hold up as soon as a client starts using this,
right.
Or 10 clients or 100 clients. And
right.
So like that early stage, whether it's proof of concept or just new build entirely, where the concept is proven to work, that is, I think, where we'll see a ton of, and even the layman will see a ton of benefit from having that scarred and bruised senior engineer who's been through it and is able to say, hey guys, I know this sounds great right now, and it's a maybe quick on the surface, but as soon as you start digging a little past that surface, we're going to find a whole rat's nest of things that we need to sort out in order to make this work. So it's definitely important to have that scarring if you want to get this right. And sometimes it is just like a thing that you need to mess up and talk to somebody who's been around, and how do I fix this? And you learn for the next time. But that is definitely somewhere where you're going to see it a lot.
Yeah, I've seen a lot of prototypes go to production and end up being the production system. And again, it's not a bad thing if it's generating value for the company, right? That's the hard part, though, is you have to understand what are those trade-offs around this. How long will that prototype last? Another great example that I have is folks that use sort of the Heroku type platforms. And again, I'm not hating on Heroku. It does a great job for what it does. But also Azure to a degree has this problem too, where you start out using a service, but as you continue to scale it, the costs of scaling that become intractable. I remember tuning a Ruby app in Heroku, and it was incredibly expensive, and it's possible I was doing it wrong. But let's say for a second I wasn't doing it wrong, because I do know a thing or two about optimizations. But let's say for a moment I'm doing it wrong. At the same time, the costs of of an average person or a mid-level developer to come in and make the application scale should not be incredibly painful. And this is, again, early on in this company that I was helping's life cycle, they didn't need scale, but they called me because they weren't able to scale and they were having issues with the application architecture. It just wasn't designed to scale out horizontally. So this is another good conversation that you want to have internally with your teams. And when you're building that prototype, be it you're a giant enterprise doing some R&D, or if you're a very small company with some seed funding, or maybe you're just a basement SaaS product that you're putting together, thinking in terms of what is the long-term trade-offs for the platforms that I choose is another big piece of the puzzle, right? Because maybe we pick Amazon for now. Again, I'm not advocating. We're AWS partners, but not advocating for them or selling their stuff. But maybe you pick Amazon for now, knowing that it's more complex because you have to have the right subnets and you got to understand a little bit about networking, or maybe you can use one of their like AppSale or Elastic Beanstalk or something like that. But let's just assume for a minute that you're using more complex networking stacks. Once you've got your app up and running, you can scale that out horizontally quite cheaply, especially if you use something like Docker. Which would also get you into a Kubernetes cluster down the line on a different cloud if you hate Amazon. Like there's lots of trade-offs, but learning Kubernetes is difficult. It takes a hot minute to really kind of understand how to deploy into it and how to use it, right? It's not as easy as simply git committing into a branch and Heroku builds your container and throws it up there. But again, you're paying for that. So it's thinking in terms of economics is not just limited to just tech debt and the layers of each feature and how I'm building that feature and the maintenance costs of making changes from either a generic or specific perspective, but it's also based on how and where you're hosting that application. You want to think about what are my trade-offs of spending the brain capital or even the real capital, the money, to go into an existing system that is either more difficult to use but more scalable, or less difficult to use and more expensive. Making those trade-offs is something people usually don't do at the early onset of the app as well, which I highly recommend that people think about where they're going with this, with their scaling and their SRE and their DevOps sort of capabilities.
Yeah, I mean, that was one of the first questions that I asked to a couple people when I started projects was, what's your user base? How many people would you ever in your wildest dreams foresee this using, and where are you at today?
Right.
Because if we need to make the investment to make this thing only scale to 1,000 users, like, okay, that's not something that I'm going to lose sleep over tonight.
Right.
But if you tell me this needs to potentially be available for 1 billion people at a time, like, we have a totally different problem to solve before we can even get to some of these features that allow that 1 billion people to be able to use this thing.
Right.
So it's definitely a conversation where if we don't have the skills on it today, it is significantly easier, in my opinion, to learn while the application is small. And we can make some mistakes, and it's not trying to untangle a mess of, 10 different services or whatever the case is, and where something broke. The earlier you can sort of set that architecture in place to be able to make that scaling relatively easy, makes life so much easier. And hopefully you do get to that point. But if you don't get to that point, like, at least the architecture is solid, and that skill is something that your team has picked up and is more comfortable with. So the next time when that next project, comes down the line, we're ready to go, and we don't have that huge ramp. It's not a question of how do I set this up to be able to work for massive loads. It's just a question of, do we think we're going to get there? Should we, spend the time now, or, are you only ever predicting 100 users because you're only targeting a very specific niche, and that that's where you're at.
Yeah, and generating that story, I think, is very important. Think of it this way: you have a lot of local maxima, right, in your journey. So for every iteration of your product, from the MVP or the prototype on out into version 1, version 1, 2, 3, 4, blah, 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 whatever your great idea, whatever your giant idea is you want to build a story of how do I maximize the economics for this local maxima, right? Thinking back to statistics. So their local maxima and then their global maxima. The local maxima is where I'm at on my journey right now, where I think I need to go. And then the global maxima is as high as you think you could ever go, period, right? So if you shoot for as high as you think you could ever go right now, you're going to spend so much money that you're never going to produce value that will get you there in the first place. So I like to think of it as for each iteration of my journey on the way to having, my $1 billion company product SaaS thingamajig. I'm looking at the local maxima around me and I'm optimizing for that and just focusing on how do I get to the best version that I can get to right now, given the resources and the time that I have, right? And this is a mistake I see a lot of companies make is they focus on the global maxima. They focus on the vision of where I could be by that target end date. And you see this in big enterprises too, because they set deadlines based on sprint commits and velocity and all this other stuff that I'm going to have all my features by this date when you don't even really know if you will, because there's so much entropy between point A and point B that it's impossible to truly figure out if I'm going to hit that date without reforecasting at each jump, right? That's why I like to think of the development process as a series of local maximas, right? So where I'm at right now, what are the best decisions I can make to have my code maintainable, have a good regression suite, be able to do some refactoring, because refactoring is incredibly important to the health of your code base. It's kind of like working out or taking a walk for humans. It's a great thing to do that keeps you healthy and keeps you moving forward and gives you energy. Similarly, having a good test suite and refactoring will give your code base energy. It will allow folks to read it better and to focus on being able to make changes without being afraid, which a code base that's always moving towards an optimal state is a very healthy and a good code base, right? And so if you're optimizing for each one of those local maxima from a code quality and an economics perspective on the way to your journey, then you're going to have some iteration of good, right? It may not be perfect. It may have some technical debt, which, by the way, it's okay. I think a lot of industries have accepted the fact that tech debt is a way of life and it's a thing. Now, if you have too much tech debt, consider increasing the skill level of your engineering population. Perhaps you've commoditized too much of your code base and you're not getting back the return on investment you think you are. But let's just assume for a moment that you do have maybe 10% technical debt or maybe 5% technical debt. That's okay, right? And it's fine to let that sit. A lot of people get annoyed and they're like, well, this problem's been sitting for years. Okay, well, if it's been sitting for years, then it's probably not a real issue, right? And I hate saying that because I'm the guy that wants no tech debt. I'm the guy that wants everything perfect and glorious, beautiful code bases with, perfect testing coverage. But I know for a fact that in the real world, where economics rule our decisions, that's not possible. So we have to think about what is the smartest trade-off I can make right now that produces the best quality product for future me, so I'm not cursing past me.
Yeah, certainly. I mean, I know I've been a part of teams, and I'm probably as far away as you might ever want to get from that like perfect no tech debt, because like to me having some tech debt is fine, and it sort of shows me that we're not spending an unhealthy amount of time shooting for perfection when good enough gets us there. Right. Now that's obviously a balance that comes with experience. It comes with good product leadership, and it comes with good communication between teams. But I am certainly a person where like what you said, if it's been hanging out there for a couple of years, like, yeah, listen, if it bothers you that much, like go spend a Saturday afternoon to fix it.
Right.
But ultimately that's not going to get in the way of me moving forward and driving more value for the company. But on the flip side, like I'm certainly not going to sit here and say, hey, we have 100 tech debt tickets that, we should get to because every time we add that next layer, like you were saying in the beginning, like we're adding 5 more tech debt tickets, eventually it's going to be unsustainable.
Correct. Yeah.
So, I certainly would never advocate for, forget the tech debt and we'll look at it in November, because we'll have a calm time of year and we can just knock out a whole bunch of tech debt, and we're solid for, that after code freeze January. But, at the same time, having some tech debt sort of lets me know that we have a healthy organization, in the sense of there's good communication, there's solid leadership, people are talking to each other, and we're trying to make that best decision for, value of the work that we're doing.
Yeah.
If we spin wheels on tech debt forever, we're never going anywhere.
What I found in that case, Sam, is if you have an extraordinary amount of tech debt and it just continues to compound, you've made one of a few critical mistakes in the beginning. One is you have over commoditized your workforce, where again you've chosen to have lower cost, less skilled labor to produce your code, and there's nothing wrong with this. I'm not attacking anybody, and that's completely fine. There's a time and a place where that's important, or you have decided to not do some of the baseline things that we know you need to do in order to produce a code base that can avoid tech debt. Similar to getting a vaccine to avoid the flu every year, writing tests helps you protect against tech debt, because you can go back through and do some refactorizations and some modifications of your code without fear of it breaking. Because the worst thing as a business owner, you don't want your software down because you're not making money. You're angering your customers. You're causing lots of sort of mental anxiety and gnashing your teeth because the key asset for your company is not up and doing the thing it needs to do. Having good test suites and having good testing practices will solve for that, probably to 95%. I don't have any actual data for that. That's complete anecdote. But I just my 15 years of experience doing this tells me that the better your test suite is, the less likely you are to run into those kinds of issues, right? And so those big mistakes are things you need to solve for very early by setting good baseline practices that the entire team moves forward with. And at that point, those extra, 2 or 3 tickets that come every layer where you have to make a specific trade-off become a lot less of a problem, and they become a lot more quickly mitigated because you have a framework in place so that you can, have, a junior software engineer knock something out real quick, right? Which is something I used to get all the time. Is when I was beginning my career, they'd give me all the little bug tickets that nobody wanted to work on because that's just unfortunately the way it was. But I learned from those bug tickets, and they're a great way to learn the code base. So, but Sam, thanks for joining me. This is a very fun conversation and a fun topic. I like discussing these trade-offs, and these are very difficult trade-offs to make when you're on the ground and doing your work. So I'd love to hear more from anybody in the comments about the types of trade-offs that you have made. I think it's a very important thing to think about as you continue to build, either from a startup or you're a giant company doing R&D. Focusing on the practices that allow you to make those trade-offs quickly will help you win more. And that's what we've seen on the ground. But thanks, everyone, for your time. Have a great rest of your day, and we'll see you on the next one.